Suppose that f and g and their derivatives with respect to x have the following values at x equal to 0 and x equals 1. F of 0 is 1, g of 0 is 1, f prime of 0 is 5, g prime of 0 is 1/3. F of 1 is 3, g of 1 is negative 4, f prime of 1 is negative 1/3, and g prime of 1 is negative 8/3. Find the derivatives with respect to x of the following combination at the given value of x. Before we plug in the number, we always need to differentiate it first. If this is the y expression, then y prime equals 5 times f prime of x minus g prime of x. And then y prime evaluated at x equals 1 is 5 times f prime of 1 minus g prime of 1. 5 times f prime of 1 from the table is negative 1/3 minus g prime of 1 is negative 8/3. And so this is negative 5/3 plus 8/3, which is 3/3 or 1. For part B, if this is y, then first we would need to differentiate to get y prime using the product rule. The product rule is f prime of x times g raised to the third power x plus f of x times, this is the power, so we would multiply 3 and then g squared of x times g prime of x. Don't forget to multiply the derivative of the inner function, and then we would plug in x equals 0. And so this is f prime of 0 times g of 0 raised to the third power plus f of 0 times 3 times g of 0 raised to the 2 times g prime of 0. And so basically, everywhere we see an x, after we differentiate the function, we would replace x with 0. The notation g cubed x means the entire function g of x raised to the third power. Similarly, g squared of x means g of x raised to the second power. We then read off the information from the table. F prime of 0 is 5. G of 0 is 1 plus f of 0 is 1 times 3. G of 0 is 1 times g prime of 0 is 1/3. This is 5 plus 3 times 1/3 is 1, so we end up with 6. Next, part C, y prime, this is the quotient, so we would use the quotient rule. First, we square the denominator. The numerator is f prime of x times the denominator, g of x plus 1, minus f of x times the derivative in the denominator is g prime of x, and the derivative of 1 is 0. And so we evaluate the derivative at x equals 1 because we were told x equals 1. Everywhere we see an x, we would replace x with 1, g of 1 plus 1 minus f of 1 times g prime of 1, g of 1 plus 1, and then squared. F prime of 1 is negative 1/3, g of 1 is negative 4, and so f prime of 1, negative 1/3, g of 1 is negative 4 plus 1, minus f of 1 is 3, and g prime of 1 is negative 8 over 3 over g of 1 is negative 4. Simplifying this, we have negative 1/3 times negative 4 plus 1 is negative 3 plus negative 3 times negative 8 over 3 is a plus 8 over negative 3 cubed. Negative 1/3 times negative 3 is positive 1. 1 plus 8 over 3 times 3 times 3 is 27 with the negative. And this is negative 9 over 27 or negative 1 over 3.